SwayamPrabha. Digital India. Educated India.
Hello everyone. So, we are discussing the ballistic protective textiles. So, this we can divide into two parts. One is soft body armor and the hard body armors. Hard body armors are normally not from textile material. So, you can see we have discussed in the last class ceramic plate, steel plate, high performance polyethylene, or we can use textile as a composite material here. So, composite way we can use. So, in the protective armor, what we use along with the soft body armor, we depending on the thread we insert the hard body armor. And also we have discussed the mechanisms of that hard body armor, how the impact force actually that is absorbed and what happens to the hard body armor, like first initial contact and elastic wave propagation. This we have discussed here. Elastic wave propagation was there, so compressive waves and transverse shear waves are propagated. Next is blunting and cone formation. So, blunting of the projectile or bullet here, and then cone formation is there, tip deformation will be a tip blunting. Next process mechanism we have discussed, the third stage dwell and crushing will be there. So, dwelling of projectile and dust starts forming due to the crushing of the hard body armor, and fourth stage was that fragmentation and matrix failure. So, then here there will be fragmentation will be there, and the fifth stage, which is last stage, is that performance, complete perforation will be there, and residual energy will be absorbed in the next layer, and spalling of the fragmented particles will be there in the next other side of the strike. So, that these are the different mechanisms, different stages of bullet penetration and the energy absorption. This we have discussed in the last session. Now, here the necessity and applications of hard body armor. What are the areas we require, where in the particularly in military operation. So, this is the standard for a soldier in combat situation and to protect them from the rifle fire. So, that is for extreme condition we need hard body armor, soft body armor will not work there, and in place of law enforcement, that tactile team and officers of high risk region. So, where threats are there, that is threats are beyond the typical handgun, hand ammunition. So, there if we think there is a high risk, so in those places we use hard body armor to protect us, and high risk environment like necessary security professional where high threats are there, like shooting attacks and all. So, this all these places we need hard body armor. So, basically the limitations are there. Main limitation is that it is heavy in higher mass, and also it is not flexible. So, weight is a first limitation, the hard body armors are typically made of metal, okay, and ceramic. So, heavier than soft body armor. So, which actually impact its mobility of the wearer and effectively the comfort and ergonomics are affected. So, mobility due to its rigid structure, it will restrict the movement of the wearer, okay, and if wearer does not move freely, then in the critical condition, that is tactile operations, that will restrict the body movement, that performance will not be optimum, and blunt force trauma is also there. So, in case of, unlike the soft body armor which absorbs the energy by penetration, but here while projectile actually protect against penetration, here penetration is not that high, but the hard body armor which damage due to the that impact force. So, blunt force is there which actually caused by the bullet. So, this is totally stiff material, hard body armor. When something strikes, so some hard particle like bullet, it strikes, and here there will be impact, and due to the lower capability of this energy absorption, that blunt force trauma which actually may impact the wearer. Okay. So, now we will discuss different test standards. So, majorly there are two types of standards available, particularly which are mainly worldwide they are used. One is NIJ standards 101.06. This standard is for basically armor, ballistic resistant body armor. Okay. So, 101.06, this standard is for body armor, and the standard is NIJ standard, and another standard is NIJ 108.01. This is not for body armor, but apart from body armor, any material, ballistic protective material like any in the vehicle, protective plate, any material, for those we use 108.01. So, two NIJ standards are widely used worldwide. Apart from this, there are other standards like NATO standards are also used. First, let us try to understand what are the differences between NIJ 101.06 and 101.01 standards. So, basically this NIJ is National Institute of Justice in US. Okay. So, that they formulate the standards, and from the materials point of view, these two standards have certain differences. So, NIJ 101.06 is basically for body armor, and this one is for 108.01 is for other material. That is why as far as material point of view, they will have certain different procedures. Basically, we need different types of materials, although the maybe protection level we need same, but material difference will be, because 101.06 is basically for the body armor, which the we used to wear basically, and where we need comfort to be incorporated, and NIJ 10801 may or may not need that requirement. Even 10106 there is a weight constraint and the mobility constraints are there. 10801 no such considerations are there, but still we need protection. Now, let us discuss the both their differences. So, 10106 basically this standard is specifically for body armor. This is important. This is specifically for body armor like bulletproof vest, hard body plate. So, which we are wearing basically, and this is worn by the law enforcing officials or military personnel. So, this for this, so we are to wear this 10106 standard, and 10801 standard is basically for the ballistic resistant protective materials, any material, that can be any material used for other things other than the body armor. So, as these are specifically for the things which are not used for body armor. So, here weight consideration and the ergonomic things are not that important. Next is application. So, here the NIJ 10106 is basically this is for vest, armor plates worn on the body. So, anything related to the body armor. So, it may be in the it is a vest or maybe armor plates which are actually kept along with the soft body armor. Whereas, 10801 is material used for fixed or portable structures like ballistic shield, transparent security glasses, guard booth, okay, armored vehicle panels. So, any that guard booth where there are threads. So, any material that we can maybe in the fixed place like guard booth or maybe portable structure like vehicle panel. So, this type of even guard booth or the portable structure we can actually put it some specified places. So, NIJ 10801 these are for materials other than the body armor. Next, now what type of conditioning is required? So, here conditioning if you see in both the standard they have the entirely different types of conditioning. So, 10106 the conditioning is required because people are using they are wearing that type of vest. Okay. So, here that is why the tests are very strict here. Okay. It is a very stringent requirements are there here because people will be wearing that this material. So, very strict including the armor for durability by tumbling it. So, they have to wash it. So, during washing what are the different types of durability tests are there, so that we have to see. Even during washing that soaking in water that should be considered. So, during conditioning exposing to heat and humidity before shooting it. So, basically this we are trying to simulate the actual wearing condition. It is not that directly we are producing and going it for test, giving it for test, but it is not that. We have to first condition like in normal wear condition, okay, wear situation like tumbling it, we have to soak in water, we have to expose in heat and humidity, which is normally the people experienced during the operation. So, that is why to simulate all this real world wear and tear condition we have to do, but here in the NIJ 10801 that type of stringent requirement are not there, because this method is much simpler. So, typically required only the test specimen kept in a normal room temperature, that is a thing. Here the soaking and exposing to heat and humidity are not required. Here we have to keep in the conditioning room with the temperature range between 20 to 28 and for 24 hours, that is all. So, here we have to keep the ballistic material, and before we test we have to condition with a very simple condition in within a normal room, and for 24 hours if we keep, then we can test. And next is the shot placement. So, here the tests as per 10106, which is for body armor, test require shot for a specific pattern is required. So, this we will discuss what type of pattern we need, okay, including the shots near the edge. Suppose this is the body armor, okay, body armor shape. Here it is not that we will always have all the shots at the center, it is not that, because in normal case there will be some shots at the edges. Okay. So, at the edge also we should know the protection level. So, here that is why the shots has to be selected in the edge also and also at the near the center. So, that we will discuss in detail. So, including the shot near the edge of the armor, which that is mainly to ensure it provide reliable protection across the entire surface. So, it is not only center. So, entire surface, whether it is able to protect at different angle. So, all these things are to be considered here, but in case of NIJ 10801 standard, so requirements are different. So, this is basically it is a more general, whereas in NIJ 10106 are very stringent requirements are. So, here the shot placements are in basically it is general, anywhere it can you can have shot. It requires that heats to be spaced basically typically 5 centimeter. It is not, this is a plate here. So, we need a heat, it should not be very close to that. So, heats to be placed at least 5 centimeter from other. Okay. So, one heat is if it is A, B heat should be at least 5 centimeter or more. So, otherwise there may be some damaged portion, and if we heat close to that, that may give some wrong result. So, minimum at least 5 centimeter from the prior heat, or it should not be at the edge also. In case of 10106 we need the heat to be close to the edge, but here it should not be at the edge, it should be at least 5 centimeter from away from the edge. So, that we can get overall general idea about the material. One 10106 basically it is having different levels, we can express it into 5 main levels we are. So, 2A, 2, 3A, 3 and 4. As we increase from 2A to 4, so the threat level increases. So, different types of level. So, 2A being the lowest level and 4 being the highest level of protection. So, in NIJ 10106, so these 5 levels dictate the specific type of armor ammunition that the armor must stop. So, there are different types of ammunition. So, it is specified. So, if the armor stops that, then we will grade that as a particular that level of grade. And in the NIJ 10801, here also similar system is adopted here, okay, level 3, level 4, level 4 like this, and to define different types of threats the material can withstand. So, levels for both the standards, it is almost same. Now, let us try to understand the different levels. So, the key points which we have discussed here: ballistic resistance of body armor. The key points are that this is the current minimum performance standard for personal body armor. So, NIJ 106, this is for personal body armor, this standard, and it specifies the performance requirements and detailed test method for the body armor intended for protecting against the gunfire. So, if we try to develop or if we try to have some body armor, we must go through this 10106 standard. It should be actually acceptable, and here 10106 it suppresses earlier standards. So, NIJ 10104 and NIJ 2005 interim requirement. So, this is the latest standard. This is the latest standard we follow. And the standard scope is limited to ballistic resistance only. So, it does not cover the threads like cut, knife threads or any sharp threads, slash threads. This does not cover, only the ballistic resistance. For cuts test or slash test or stab by knives, we need different types of test, and here ballistic test by bullet, so gunfire. So, for those tests we need this type of this NIJ 10106. Okay. So, the classification, as I have discussed, different types of classifications are there, and the types are basically that depends on the threats. The classification based on types or threat level. So, you can see here. So, 5 main types that I have already mentioned. So, type 2A, 2, 3A, okay, 3 and 4. So, the threat level increases in this way. So, based on the ballistic performance. So, if some body armor is labeled as 4, that means it is a maximum protection level, and 2A means minimum protection minimum. So, for low level of threat we can use 2A. And this 2A basically for flexible armors. So, you can see this lower level for flexible armor, like lower level of threats, handgun and threats are there. So, 2A protects against 9 mm 0.40 S and W, that is Smith and Wesson and Winchester. So, this is the S and W stand for. So, they have developed this cartridge, this is the type of cartridge in 1990s. So, this cartridge is developed in 1990s. So, what does 0.4 means? 0.4 stands for the diameter of the bullet. So, 0.4 inch diameter and 9 mm is the this 0.4 inch. Now, type 2A, so 3A is the that type of threat. 2A, this protects against 9 mm 0.357 magnum. So, 0.357 magnum is a powerful handgun cartridge introduced in 1935. Here features that 9.1 mm diameter of bullet. So, that is the different diameters of bullet. 9 mm was the diameter, and the 0.357 refers to the bullet caliber, while the magnum is a Latin word for large value. It signifies the high performance, high pressure version of the older version. So, that is the some modified version, it is a higher threat. And 3A is protects against the 0.357 SIG and 0.44 magnum. Okay. Earlier it was 0.4 magnum, here it is 0.44 magnum. Officially that is SIG. So, this type of high powered large caliber cartridge primarily designed for revolver and hunting rifles. So, these are the different types of threats and the protection level for mainly for flexible armor and for the higher threat that is a rifle threats, where we need higher protection level for particularly for hard armors. So, hard armor we use the type 3, for hard armor we use type 3 and type 4. So, type 3 protects against 7.64 full metal jacket rifle bullets. So, M80. So, that is the definition of the threat. So, 7.6 mm full metal jacket rifle bullet of M80. M80 refers to the standard issued in NATO. So, 7.62 by 51 millimeter NATO ball cartridge. So, M80 is designed for general purpose military use. Typically weight is 147 grain. So, full metal jacket FMJ bullets, they describe the bullet construction here actually total metal jackets are there, a lead core encased in a hard metal jacket. So, that this is the type of bullet we are talking about. So, for that we need type 3 level of body armor and type 4 so protect against a 0.3 caliber armor piercing. So, AP bullet. So, M2 AP. So, M2 AP stands for M2 armor piercing ammunition. So, armor piercing ammunition means high latest ammunition. So, there we if we have to protect ourselves, we have to have some body armor with type 4. So, these are the different levels of body armor as per NIJ 10106. So, this is basically type 4 is a military grade cartridge featuring hardened steel core. So, this M2 AP it is a military grade. So, hardened steel core to penetrate armored target such as light vehicle, masonry and protective plate. So, this is very high penetration rate. So, this type of it is meant for the penetration. So, for that we need body armor of level type 4. Even apart from this, on special type classes exist armor to validate against non-standard threats. So, these are the standard threats, but for special we can have body armor with a special type if the threats as we have specified they are not standard beyond this all the known threats. So, then we can have some special type class. Now, the main key points for testing. So, for any standard we have to follow some key points, key definitions. So, key points that we have to follow before we do any experiment. So, we should clearly follow this terminologies. First is the fair hit. So, in any armor for any body armor test, we used to hit with the some projectile, some handgun and some type of rifle, but not always all the hits are counted. So, there has to be some fair hit. So, this bullet impact has to meet some standards for some velocity it should have some spacing and angle, like this is our armor which we are testing. The bullet velocity V should be taken into consideration, and also the spacing between consecutive hit has to be considered, and the angle. So, this angle should be ideally 90-degree angle, exactly vertical to the surface, but little bit tolerance can be allowed. So, maximum 5-degree deflection is allowed. So, that is why if all these conditions are met, then we can call it that the hit is called fair hit, and that fair hit would be taken into consideration for grading this body armor. Then penetration. So, penetration and any impact where the projectile passes into the armor is penetration. So, there is a armor and the projectile, the bullets hit. So, they will penetrate somewhere. It may penetrate through the this armor or partially penetrate. So, penetration has to be taken into consideration, and we have to specify with the test report and back face signature. So, for any test there is a our armor to be tested, and at the back there is a bullet hit. At the back there will be a soft material like clay, okay, like clay backing materials are there, and when this is hit by the that bullet, there will be some deflection due to the cracking or due to the penetration, and here in the on the clay there will be some deflection, some it will get some, it will get deflected, and that deflection is measured. So, the depth of indentation, so there will be some indentation left by at the clay backing material by the bullet, and that did not perforate the armor. So, it is not perforated, but there will be some impact. Due to the impact, there will be at the other side of the this armor there will be some deflection, and that deflection is actually this indentation is measured, and this is actually the measure of blunt trauma. Suppose someone is wearing on armor and bullet is hit, it is not even penetrated, but due to the deflection of the structure of the armor that actually hit the body of the wearer, and that trauma depends on the how much depth it has deflected, that we try to measure by the term back face signature. So, at the back of the this at the back face how much it is deflected, that is that we try to measure. So, which actually the person may not die, but there will be severe injury will be there, even if it is it may actually may be sometime fatal if the back face signature is very high. Next is the backing material. So, for back face signature measurement we need some backing material. So, this is a homogeneous block of non hardening material, that is important. It should remain soft for some time, for a long time it should remain soft, because non hardening material we cannot use any material which gets hardened quickly. So, oil based molding clay, so that is the material which is placed in contact of the material at the that armor at the back side. So, typically it is oil based molding modeling clay. So, that normally we use this modeling clay we use, and which is oil based, so that it does not harden quickly, it remains soft. And another advantage, another requirement is there why it is oil based modeling clay is that after deformation it will stop at that point, it should not come back. So, when suppose it is a deformed, so there is a signature is there deformation, it should not, due to elasticity it should not come back. So, it should be least elastic material that we have to use. So, and next is the ballistic limit. So, here the velocity at which a bullet has a 50% chance of perforation of the armor. So, that is the 50% chance is that ballistic limit is expressed in V50, that we will discuss in detail. So, we will start with the lower velocity and then we will keep on increasing the velocity of the bullet, and that as the velocity increases, so there will be perforation. So, we will do all the experiments, not that the velocity will be always there which will be stopped. It is not that, we will plot the velocity versus the perforation, and that where 50% chances are there of penetration, that will be called as ballistic limit. It is not that ballistic limit, typically we the term we mean, we sometimes we think that it is there is no penetration should be there, that is the limit, but it is not that. At that velocity, if we suppose ideally if we think that we hit say 10 bullet shot, at least at that speed we think that at least 50% will be there which will perforate the armor. So, that is the speed. Now, we will start this to understand in detail one by one. First, let us try to understand what is fair hit. So, fair hit, as we have mentioned, in any test there are three conditions for a bullet impact to be valid. If it is not fair hit, we will not call it, we will not take into consideration that hit is not valid. Under three condition we check the validity of a particular shot. Its angle. So, the angle must, the bullet must hit at an angle, a very direct angle, that is 90-degree angle. It should hit exactly, this is the panel, the bullet should hit exactly vertically at the direct angle. So, it is a 90-degree angle should be there. But the allowance is that plus minus 5 degree. Okay. That is the, if it is within that range, we will call it as it is coming under the fair hit zone. So, angle of incidence or obliquity, the fair hit is typically defined as a bullet impacting armor at 90-degree angle perpendicular to the surface or within specified plus minus 5 degree. That is angle. Now, we can see here. So, in this particular test, here is the barrel, okay, and there will be hit, bullet hit from this side, and here there are velocity sensors are there. This is typical test setup of different distance it is placed, and here there is a armor which is target, and the support is typically it is a back face signature, and witness plates are kept just in case of any perforation. Now, here this is the, it should be 90 degree typically, this angle of hit should be around 90 degree. next is of fair hit is the distance. There is specified distance. So, between the two hits. So, one hit if it is in this place, next hit should be at least 5 centimeter distance. So, if it is this is say 5 centimeter. So, up to this point it is accepted, but if some hit is within this zone, so this is not accepted. This one is first hit, second they are correct, and third one is rejected. So, it should be at least 5 centimeter away from any other previous bullet holes. So, this is the first bullet hole is here, okay. Second bullet hole is okay here, third is here, these are okay, but fourth one if it is within this 5 centimeter, this is not acceptable. Now, here we can see the hits are in this way, we have to hit in different ways. Now, third fair hit is the velocity. So, here the velocity is we have to select the velocity in such a fashion the bullet must hit the material at an acceptable speed. Okay. The speed should not be that high that it must not go through the test specimen. So, here what we are doing trying to tell here there is a bullet is there, okay. This is the bullet, and if it the v is the velocity, at that velocity if it penetrates through, then this velocity will not be considered. Okay. So, that how we have to see. So, if a shot meets this all these 3 rules, so it is not the only one, 3 rules has to be met: speed, angle and distance. The 3 rules has to be met, then only we can call it as fair hit. So, first we have to have some fair hit, then only we can start testing. Without fair hit, we have to reject that particular shot. Second is the penetration. Second key point is penetration. So, a penetration may either a stop or perforation. So, this is the armour. So, a bullet may be stopped here, okay, or maybe complete perforation is there. So, these are penetration, or maybe at this time it has not perforated through, but it is perforated, but it is not moved through this structure, crossed the structure. The result is considered as stop or partial penetration. So, either it is stopped or partial, this is a stopped, okay, and here it is a partial penetration. So, in 2 ways we can consider. Okay. So, if it is stopped within within the structure. So, if it is stopped here, or it may be partial penetration, or maybe here it is stopped here, stopped partial penetration or partial perforation. So, if the entire projectile is captured or deflected by the armour, or second, if no fragments of either the projectile or armour become embedded in the backing material. So, that is called the stop or partial penetration. So, here backing material is there. So, at the backing material there is no, this is backing material. So, where no fragment of either projectile or the armour which are embedded in the backing material, in that condition we can consider. So, if any part of the projectile passes through the armour and that result is considered as perforation or complete penetration. So, that is this is if it passes through the armour. So, if it is going in the other side, so then we will call it as perforation or complete penetration. So, confirmation of the penetration is that how to confirm if any of the following events. What are the events? So, these are the events. If any of the following events happen, then it will be called perforation. Now, what are this? This is the body armour and here is the, this one is the backing material, clay backing material. The presence of the projectile part that we have discussed, okay, a fragmented projectile or the armour fragment. So, you can see here armour fragments are there and projectile fragments are there in the clay backing material, then we will call it as perforation. So, that scenario if it is there, then we will call it, this is perforation. Second one is that is penetration, this is penetration. Second one, a hole that passes through the armour and the backing material. So, there will be complete hole will be there, then we will call it as a perforation. So, complete hole, and also there will be in backing material also. And third one is that, so any portion of the bullet which are visible from the body side of the armour panel, that is if the armour is there and on the other from the other side. So, any part of the bullet if it is actually visible there, then we will call it as, suppose if this is the body armour and if some part partially, so then we will call it as perforation, some part is actually visible. So, after bullet hit, bullet is caught there, it is restricted, then we see the other side, body side, and there we can see clearly that whether there is any perforation is there or not. Next parameter is the back face signature, which is very important, which actually simulates the trauma. The greatest extent of indentation in the backing material caused by a non-perforating impact on the armor. So, that as I have already mentioned, this is armor. When there is a heat, suppose there is, it is not perforating, there is no perforation, but still due to the impact there will be deflection, and this deflection is actually captured by the backing material, soft backing material, and there will be deflection. So, that is actually called back face signature, and this is basically the perpendicular distance. BFS is the perpendicular distance between the two planes. There will be two distinct planes. First plane is the both which are parallel, okay, two parallel plane at the heating point, when it is heating at that a reference point, and at the maximum indentation point, this distance. So, first heating point is here. So, that is pointed, this is the first heating point, that is reference point, and after heating there is a deflection in the backing material, and which is the maximum indentation point, and this parallel distance is called back face signature. Now, this back face signature here, we can have this back face signature for both flat portion or even a curved portion. In a flat portion it is very simple, we take the reference point here, this is that just at the back of the this is armor sample, at the back side of the armor sample or at the top side of the backing material, and after heat, this is the before heat and this is after heat, after impact, before impact. After impact there will be deflection. So, from here we know this is the reference point, that plane is there, and after that this deflection will be. So, this is a simple one, the distance we can get the back face signature, but for curved portion we have to take the point, reference point where it is actually hitting that point, that below that point, that is the reference point. This plane we are taking, this line, and maximum indentation point. So, and you can see the back face signature here. Now, from this point you can, this is the reference point, and here this reference point becomes at this point, this and here this is the back face signature and maximum indentation point. So, distance between the this initial reference point and the maximum indentation point is back face signature here. So, next is the backing material, what type of backing materials are there, and that we will discuss in the next session. Till then, thank you.